In this video, we're going to be taking a 700-pound piece of 4140 and we're going to process it in our brand new tree mill VS1614. All right, the first tool we're using today is the Harvey 2TE. We're going to make a little 5-inch circle that's just enough for our feed mill to plunge into and start working its way out. Now the part that we're going to be making is 27 inches in diameter and 5 inches thick. And if you take a look at my screen here, you'll see the big Blisk that we're getting ready to make. Now, for our first operations, we need to do a prep op so that we're able to get it on this fixture. Now, this fixture is going to be used for our second and our third operation, but for our first op, we're just going to toe clamp our stock to the table. So in this configuration, we have a Perrone HSK 100 spindle connection, and that's one of the most rigid spindle connections on the market. We got plenty of power, so for continuous, we have 38 kilowatts or 51 horsepower. For maximum, we have 44 kilowatts or 59 horsepower. We also have plenty of torque available, so for continuous, we have 302 Newton meters or 222 foot-pounds, and for maximum, we have 352 Newton meters or 259 foot-pounds. Then we also have 15,000 RPM. Now the table on this machine is also pretty impressive. Now we're holding a tiny little 700-pound part, and this table can hold up to 6,000 pounds. Now that's pretty impressive when you consider this is a 5-axis mill. The table can swing 90 degrees toward me or 90 degrees away, so all of that weight is just hanging out there in space while we're machining. In addition, we have the new Heidenhain TNC7 control. Now this is a pretty powerful control, it's pretty user-friendly, and you can see my favorite part, I'm running it in dark mode. Now the reason I chose that tool is because it's got great ramping capability and really good step over capability. This is the tool you see us full slot with a lot. Now you see our high feed mill. I didn't want to plunge straight into the material with this, and I didn't want to do a ramp because it was going to have to be a pretty wide diameter circle to make a ramp without the material getting wedged in the ID of our cutter. We're running it 60 thou deep at 350 inches a minute, and that's cruising for a high feed mill with that big of a diameter. All right, here comes the high feed mill of doom. I haven't used this bad boy in a while. Yes! Now, if you look at my screen, you'll see we're leaving a cusp right there. That doesn't really bother me because we're going to come in and do a semi-finished pass with the Harvey 2TE end mill after this. The reason that we're using the Harvey 2TE to do the finishing is because I want to make sure that we have a very flat surface, or at least as flat as possible. By using an end mill, it's almost like hand scraping, and we're going to get a lot more surface contact when we flip this over on our VS modules. Oh, it's like butter. Not even any steel there. Yes! 60 horsepower and 260 foot-pounds of torque in full effect. And just think, this is the smallest machine that Tree Mill makes. "350 inches a minute of metal brutality." This is it. This is what I love. All right, so now that we roughed away the majority of the material here, now it's time for us to come back in with the Harvey 2TE and get the angle corners that the high feed mill didn't get and give our floor a nicer finish. Now everything that we're doing in this operation, I'm leaving about 100 thou stock. And that's because I don't need anything on this face to be finished. All I need is to be able to clamp this part on the VS. I need a flat surface and the 4 counterbore holes. Now, even though big machines are a lot more fun, they're also a lot scarier. So for our second operation, we're gonna put this thing like 10 inches up in the air on our VS base. And when this table kicks 90, I'm really hoping that I remember to lock the VS system and the part doesn't just go clunk into the bottom of the machine. Even though our viewers, I'm sure, would love to see that, I wouldn't. We ought to start making some pockets and some big blue chips again. Now we come to our 1-inch go-tip drill from Kennametal. This thing's gonna just pop a few holes, and these will be starter holes for our Harvey 2TE to come in and cut our pockets. What we're doing is really hoping that our post-processor is set up correctly and that this drill is going to drill a hole and then come back out before it rapids over and does another one. So here we go. Ow! Go, tip, go. Yes. Success. All right, now it's time to bring our 3/4 end mill back in, and we're gonna make 8 out of our 12 pockets. Is that correct? Yes, 12. Now the reason I'm putting these pockets in the first operation is just because I want to kind of lighten this stock a little bit. We're gonna be pretty far up off of our table, and this part weighs 700 pounds before we start taking away all the material. When you have your B-axis flipping around, you want to make sure that you consider the centrifugal force that's going to be involved there, because we don't want this part flying off the table and through the doors onto my feet. Now, this machine is built like a tank. If you take a look at the way that that spindle is sticking out right now, it's like 5 feet long. But what they did is they put a linear guide on all 4 corners of the spindle. That way, like with a traditional bridge mill, you only have 2, and your spindle's able to flex. Well, with this one, you're kind of boxed in, so it's super rigid, and that's why these cuts sound so great. So we got our pockets to full depth. Now we're coming in with the same tool and just stepping up above the radius that's in the bottom of the pocket. All right, now we're gonna rough in our pull stud holes. And then we're gonna use a 1/2" Go Mill Pro with a square corner to come in and finish those counterbore holes. All right, time to drill our holes so that we can mount our pull studs to our part. We're gonna bring in our Go drill. It's a 312 diameter, and we're going to drill the holes for the bolt that goes through the pull stud. All right, for our threads, I chose to use a single point thread mill because we have the reach that we need to get at least 1 inch deep. I could have used a multi-form, but usually they only go up to 3 times D, and I wanted to go a full 1.25 inches deep with our threads. All right, now all we got to do is cut around our ID there and deburr our holes and pockets, and that's a wrap. Let's go. All right, so this operation of the part is complete. Now, nothing on here is finished yet. We still got like 100 thou stock left everywhere. Where the 4 pull stud holes are, we're gonna end up having pockets, but we're saving that for the 3rd operation. As for the pockets that we put in, we still have over 100 thou stock left on each of those as well. So, our next part of this is we're gonna get this out of here, put our fixture in, get it cut, then we're gonna throw this bad boy onto the fixture, and we're gonna start making a super sick part. So stay tuned, you're not gonna wanna miss this. When we're running big tools and big machines and we're running through spindle air, we depend on Kaiser compressors. They're super dependable, scalable, and they handle all of our compressed air needs. If you're in the market for a high quality machine just like this one, you can contact Keith at titansofcnc.com. He can answer all of your questions. And if you're looking to learn CAD, CAM, or CNC, while you're on our website, visit our academy. We have over 700,000 students currently enrolled, and it's 100% free.
Hey, if you haven't already, make sure you check out our app, MFG Connect. It's on Apple and Android. It's pretty sweet. You can upload your projects, show off cool toolpaths, and connect with other machinists like me and Barry. You can show off your work, upload your projects. I hope to see you there.